Hello everybody, welcome to Transy Learning Physics videos. Today we'll be discussing about quantum theory, and in that we'll be discussing about quantum numbers. In this video we'll be discussing about how to find an address of an electron. That means what is the address of an electron and where the electron resides. We will be finding this address using the quantum mechanical model of atom given by Erwin Schrödinger. So let's start. In this video, we'll be covering the following points. That is the Bohr model as well as Erwin Schrödinger model of an atom. Quantum mechanical model of an atom. Then what was the aim of this quantum mechanical model? We'll discuss about principal quantum number, that what does it describe or designates. Then azimuth quantum number, what does it describe and designates. Then magnetic quantum number, what does it describes or designates. And then spin quantum number, what does it describes or designates. And then using these four quantum numbers, we will be finding the address of an electron. So let's start. First of all, we'll discuss about the Bohr's model of an atom. Bohr model of an atom was based on Planck's quantum theory. According to this Planck's quantum theory, the energy, the radiant energy, is emitted or absorbed discontinuously in the form of small energy packets called quanta. In case of light, these energy packets are known as photons. This I've discussed in detail when we are discussing about the particle nature of electromagnetic radiations. So this Bohr's model was based on this Planck's quantum theory. And as per Bohr model of an atom, electrons revolve around the nucleus in certain definite circular paths called orbits. As you can see here, these are orbits. Each and every orbit is associated with a definite amount of energy. That is the reason these orbits are also known as energy levels or energy shells. That means that as long as an electron is revolving in a particular energy shell, it will neither lose energy, neither it will gain energy. If we had to go to a higher level, then it will absorb energy, and if it has to go to the lower level, it will release energy. So the main important postulates of the Bohr's model of an atom were: first, the angular momentum is quantized. Second, the energy of electron is quantized. Now, what do you mean by this? First of all, angular momentum is quantized. Here you can see that this is angular momentum, that is mvr, where m stands for mass of an electron, v is the velocity of an electron with which the electron is revolving the nucleus, and r is the radius of an electron from the nucleus, and n is an integral. H is the Planck's constant because it is based on the Planck's quantum theory, and 2 pi is a constant. So what do you mean that angular momentum is quantized? It means that the angular momentum of electron can be equal to h upon 2 pi when we take n as 1. It can be h upon 2 pi into 2. That means 2h upon 2 pi when we are taking n as 2. Or it can be h upon 2 pi into 3, that is 3h upon 2 pi when we are taking nh3, so on. So that means that the angular momentum of an electron is quantized. Only those energy orbits are permitted for the electron in which this angular momentum of the electron is a whole number multiple of h upon 2 pi. This is a whole number multiple. N is an integral, which is a whole number like 1, 2, 3, which represent these orbits. Orbit number 1, 2, and 3. Now, the second point, the energy of an electron is quantized. What do you mean by this? This means that an electron can absorb energy only in a fixed amount. That means when it moves from the lower to the higher level, it will absorb energy. As I've told you that if it moves from the lower to the higher level, it will absorb energy. And it will release same amount of energy moving from the higher to the lower level. So suppose if an electron is here, it want to go to a lower level. So it will release the same amount of energy which the electron absorbed when moving from this lower orbit to the higher orbit. The electron cannot move freely but can only jump from one energy level to another. So here you can see this is the ground state. So if an electron absorb energy equal to the integral multiple of h upon 2 pi, then it will go to some energy level, say here, or it can go here, or it can go here. It will not behave like a wave. At one moment of time, it can absorb just fixed amount of energy and go to a particular level. And if the electron has to come to the ground level from that position, again it will release the same amount of energy it absorbed when it wanted to move to the excited state. So as per this theory, electron has a particle nature. So now I explained you the Bohr's model of an atom. Let's talk about the quantum mechanical model given by Erwin Schrödinger. So this was the Bohr model, which was based on the Planck's quantum theory. So Schrödinger, he modified Bohr's model of an atom and proposed the electron cloud model. Now, what is that model and how it looks like? It's look like this. Here you can see that unlike Bohr model, there is no demarcation of the orbits or the energy levels. This is just a cloud or a sea of electrons that are revolving around the nucleus. So fixed energy levels or the orbits or the energy, that concept is gone. And this model of an atom is popularly known as quantum mechanical model of an atom. This model was developed by him taking into account both the particle nature and the wave nature of electron. The Bohr model is based only on the particle nature of electron, whereas this quantum model is based on both particle as well as wave nature. So this quantum model gave us a broader perspective to describe the electron. Before describing the electron, we should understand about this model a little more. According to this model, nucleus is surrounded by an electron cloud, as I've discussed that there is no demarcation of the boundaries. Now, if I have to search for an electron and if I want to zoom into this model, how this model will look and where electrons can be found. So the electrons can be found in region known as atomic orbitals. What are these atomic orbitals? For understanding this, you have to take into consideration that when we are going to zoom this model, the model gonna look like this. In this case, you will see that there are some orbitals like 1s, 2s, 2p and 3s, and they have different shape. You can see the S1 has the spherical shape, where the P1 are the dumbbell shape that you can see. So what are these atomic orbitals? Atomic orbitals are the probable region of space that surround the nucleus in an atom. These orbitals are region in space where there is a possibility and the probability of an electron to be found. So you can see here that these are the regions where we have the possibility and the probability of finding an electron. So now there is no fixed criteria of finding the electron. We are just on the possibility and the probability concept, right? And as you can see here that you have different shapes. I've discussed about the different shapes when we are talking about the atomic orbitals in detail. Like s orbital have spherical shape, whereas p orbitals have dumbbell shape, and so on. So we have discussed in a different video. Here I'm just giving you an idea of the atomic orbitals. So when we're going to zoom in, the structure of an atom will look like this, and here we have the probability and possibility of finding the electron. What was the aim of this quantum model? So the basic aim of the quantum model was to fully describe the electron. That means to find the address or the location of each and every electron. Now the question arises that how can we find the address or location of an electron, because this model is based on the possibility and the probability. So how can we describe it or find the address? So for that, for describing, there are 4 parameters we have to keep in mind. These 4 parameters are energy levels and size of the region an electron occupies, then the 3D shape of the region it occupies, then orientation of the region an electron occupies, and the spin of the electron. How Schrödinger described these four parameters. He used four quantum numbers to describe these four parameters. So the first parameter, that is energy level and size of the region an electron occupies, was described by the principal quantum number. You can take this as a cloud here. Now please consider this is an electron cloud and this is a nucleus with no demarcated boundaries of the electron where it is revolving. So I'm just taking a point here. Suppose the electron is present in this shell. This main energy shell, and the size of the region is occupied is given by the principal quantum numbers. So this is the first link to the address. The 3D shape of the region it occupies, that was given by the angular quantum number. If we zoom this, we are inside this energy level, right? The one which I've marked with this red. So inside this, there will be some 3D region. Again, about this, I've discussed in a different video. Here, I'm just giving you an outline of it. So you can see here spherical. So this is the s orbital that we were discussing about. Then this is dumbbell, this is the p orbital, and these are the d orbitals. So now let's suppose the electron enters this p orbital. Again, we are going to zoom in and see what happens. When the electron goes inside this, then the orientation of the region it occupies was given by the third quantum number, that is magnetic quantum number. So when an electron enters this region can be segregated into three orbitals, one aligned along the x-axis, one aligned along the y-axis, and one aligned along the z-axis. So in this case, let us suppose that the electron entered the orbital along the x-axis. Once the electron entered this is the final address of the electron here. So these three represents the final address of the electron. What do you mean by the spin of an electron? Once the electron enter this orbital, then how it going to spin, whether clockwise or whether anti-clockwise? That was given by the spin quantum number. So as you can see here, the electron has entered, so it can revolve either in clockwise direction or either in anti-clockwise direction. So basically these are the four quantum numbers which fully describe an electron. I will just review it quickly. Principal quantum number gives you the main energy level in which the electron enters. Then after entering this, it will choose the sub it will enter. In my case, I took the p orbital. Then after entering this p orbital, the electron will choose that what kind of orientation region it want to take. The one like which is inclined along the x-axis or y-axis or z-axis in the case of the p orbital. And once it enters it, that is the final address, and inside that, whether the electron spin the clockwise or the anti-clockwise. This is just a brief I have given to you. Now further going into this video, first of all, we'll be discussing these four quantum numbers. We're gonna review them. If you want to know in detail about each and every quantum number, you can watch my other video in which I have explained all these quantum numbers in detail. But further going in this video, we will be just reviewing this four quantum numbers, and using this quantum numbers, taking an example, we're gonna find the address of an electron. Part 1 ends here. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Thank you. Have a great day.